Hey, what's going on, guys? Kumaki Games here. Today is my birthday. I'm 34 now, and it just happened that I made a present for myself. So, as many of you know, well, at least for those of you who has been following this channel for quite a bit of time, that I've been developing a KIM-1 emulator in JavaScript. I didn't really write this from scratch, so it was more like bundling existing pieces of code together. So I had the 6502 processor emulator in JavaScript. I had this fantastic assembler adopted by Nick Morgan and earlier was involved in 6502 asm.com site, if I'm not mistaken. Doesn't matter really that much. But the problem was when I tried to run the original software that was initially developed on KIM-1 and for KIM-1. So one of the most outrageous games, I would say, to run on this computer is KIM Venture, and it's written by Bob Leedom. And by the way, if you're interested, I have a more than 1 hour interview with Bob here on this channel. So if you're interested how this game was created in 6502 machine codes back in the day, it was written in 1979 if I'm not mistaken, then feel free to have a look at that interview. That's going to be quite exciting. And today, finally, I've managed to adopt this game slightly a bit to actually run on my emulator. So first, without further ado, I just show you how it works. And then in the end of the video, I'll cover what I've changed in the game in order to actually make it work, make it run on this particular emulator. So here I have, so there was a hex dump provided by my friend Dominic Bambaka. That was Intel hex format. I've adopted that format, so I've just added this DCB, which I believe stands for declare byte, and the bytes themselves to be the preferred format for the assembler I'm using. So if we just grab this, so again, if you want to try this at home, that's possible. That's absolutely for free. So all you need to do, you just need to grab this file. There would be links in the description below the video. So you can just copy this and then going back to the emulator and here paste into the assembler and click the assemble button. Then it's very important to pick up the proper origin of where the program starts, for otherwise it's not going to be working properly. It's actually not going to be working at all. So here the variables should be uploaded at the address 0000 hexadecimal, and that's exactly the location that I want to specify. So here we go to 0000, okay, and upload. And now you see like it uploads the data. So if we have look 84 EF A0 EF A0 and so on until this sort of a thing. So far so good. Then the next part is the main part, so the main game part should be uploaded at 0100 hexadecimal or 100 hexadecimal. So I just grab this as well and go into here and paste, and I can actually go to 0100. It's not essential, but for now, just to show you, so there is nothing at the moment here. So if you just list the memory, there is nothing here really. So 4 digits on the left is the address, 2 digits on the right is the memory, for those of you who's not aware how the KIM-1 works. So here I just assemble, and I need to specify the origin at 0100 hexadecimal, okay, and upload, and we got the bytes being uploaded here as well. So far so good. So go into 17 and 1780, nope, 1780 like this. So it's the last part for some subroutines that are actually stored in the 6530s chips. The IO chips also contain the ROM, but they do contain 64-bit RAM each, and those addresses are used as well here. So this piece of code copy should be uploaded at the address 1780. This last one can replace the program at 0100 hexadecimal. This is the scorer program, so you want to know how much did you score in the game, right? So here paste and assemble and 1780 and okay and upload, and we got this bytes here as well. Now in order to run the program, we need to go to the address 0100 hexadecimal and click go, and now it tells us you are at string, and then it asks where to go, and this row represents the possible locations where in particular we can go. Now, it's not really trivial to try to decode this. There is an entire PDF file called KIM-1 manual, which contains both the listings of the entire, like what these bytes are, so that there is the assembly listings, and also the descriptions of how to interpret this runes. So they literally tell you where you can go, like going the directions like north, south, east, west, and also sometimes you can go up and down. Well, just to give a bit of an idea. So here is the map that I make a snapshot of, and this map is available at the very last page of the KIM-1 manual, if I'm not mistaken, right? So here you start at stream, and it's sort of a like cave crawling game, adventure game. So this is called KIM-1 map of semi-colossal caverns. Hope I pronounced this properly, right? So I'm currently at the stream, and I just know some moves that I can make because I've been testing this really heavily. So now we'll go to the house, then go down to the cellar, pick up the objects there, and then go back to the stream, to the 2-inch slit, then to the steel grate, and here we'll try to use an object that we've picked here. I'm not really good at playing this game, and again, like, the only reason why I'm doing this is just because it's absolutely fantastic piece of software that one can use in order to test your KIM-1 emulator if you're writing one. So I think like if your KIM-1 emulator would run this game, that would run whatever software. So yeah, because this one is very, very complicated. So if I just press and hold 0, I'm going north. I just know that 0 goes north, 2 I believe goes south, but yeah, I don't need go west and east because yeah, just not essential. And here the rune has changed, and this means that I can go downwards as well, and the button for that is 5. Yeah, let me just make this one always on top. So now I press and hold 5. And I'm going to cellar. So from house, I'm going to cellar. So you are in cellar, and here is the most essential thing I've been tortured by. So I see file, rope, cage, and file, rope, and cage are the objects that are about to be used somewhere on the map. And depending on how exactly you're going to be using those objects, there was a result whether you win or lose. So it's a sort of a puzzle game, part of the adventure. It's a sort of a puzzle game, so you can use the objects. I don't know how to do that, but the only thing I've been debugging is just to make sure that all the functionality, like carrying the objects, dropping the objects, and using the objects kind of works. So I just going to demonstrate some small parts. So I didn't walk through the entire game. You're free to do that, and that would be interesting if you manage to win the game. Can you let me know in the commentaries in that case? So let's say I forgot where I am. I can press B, and he tells me that you are in cellar, and I see file, rope, and cage. So if I now click this C, click and hold this C, which would result in trying to carry the object. So carry, and if I don't do anything, it would just list the available options that I'm about to carry in this particular location of the map. Okay, but if I want to carry one, I say carry, and then file, and I click again, and done. And I've spent really hours to make it work, guys. And I will, at the end of the video, I'll tell you how exactly this was possible. And now, if, for instance, we say B again, now he says you're in cellar, but now it would see only 2 objects. So I see only the rope and the cage, because I've already picked up the file. The file is kind of in my back, or sort of that. Okay, so let's pick up the rest of objects here. So carry, okay, and I want to carry the rope, done means okay, and I want to carry, what else, the cage as well, yeah, and I want to carry the cage. Okay, so now I've picked up everything. If I just press B again, for instance, it would tell me I'm in a cellar, but there is nothing there. So I've picked all the objects available, and you said you're in cellar, and just drops back. So now we need to go up, and that's the key 4. So from cellar, I'm going back to house. So I'm going back to house. You're at house. And now I need to go down to the stream, and this is 2 if I'm not mistaken. So should be you're at stream now. Yeah, indeed, you're at stream, and going down again. You are at 2-inch slit, which is fantastic. In the stream. Okay, so far so good. Okay, so I'm still going down. The still great is where I'm gonna be using file. Yeah, in the grade you need to use file to go to the tunnel. Okay, so yeah, this map is really good for debugging the game because because without knowing where actually to go, the only navigation instrument is this tiny little rune. So if you know to read this properly, you know where exactly you can go, and the game actually assumes that you're drawing this map by the time you're playing the game. So that's another fun thing, as explained to me kindly by Bob Leedom when we had our nice interview. So yeah. Now I'm going, so again, sorry, I forget where I am, guys. So you are at, yeah, 2-inch slit. Okay, so I'm going down to, not down, I'm going south to the still great. Okay, I just wait. Okay, so I'm going down. You're at still great. Okay, and now actually, so if I try to go down to go south again, it would probably tell me cannot. Yeah, because I just need to use a file here. So this E button stands for using. So if I say E, use, cage, nope, rope, nope, and file, yes, I want to use the cage. And now you open. Great. Oh my god, this is fantastic. So I've just opened the grate, and probably I can go down now. So going south, sorry, and still cannot. Maybe I just need to go down in this case. Not sure how exactly this works. So I hopefully you are in tunnel. Yes, this is win. Okay, I see rod. Okay, so probably I want to carry the rod. I don't know why, but yeah, why not to carry the rod? So yeah, carrying the rod, done. So far so good. Now I'm not sure. So this goes, so going south to go to the bird room, I believe. Yeah, is that the case? So let's try going to, nope. Yeah, maybe something wrong on this. I don't know if I try to go, nope. Well, I don't, guys, I'm sorry, I don't know how to play this. Really, maybe north. You're in bird room, yeah. So should have been going north, really. Yeah, okay. So north here, south here. So I just messed up this tiny little things. Okay, so you're in bird room, and it is. I just missed if it said I see bird. Bird room. Okay. I see bird. Okay, so here, to be honest, I have no idea how to play from this particular place. So I believe we need to put a bird into the cage, and then we'll go to the dragon hole somewhere here, and then we'll need to feed this bird to the dragon in order to make the dragon pass through. In order to pass through the dragon. And there are even settings like how hungry the dragon is. There is a variable in the source code. So yeah, but again, I'm sorry, I'm not a player. Yeah, just wanted to make sure that the game sort of playable, and it is actually. So it's all on you. You can try to play through the entire game and see if you manage to do that. And instead of playing, I would rather focus on the very last and probably the most important hack that actually made it possible to run this game, to run KIM Adventure on this emulator. So here is the deal. If we go to the listings, then we have a routine called delete object. So the idea behind this is, so the routine starts at 01EC and ends up with 01F7. So 60 stands for RAS, return from the subroutine. And what this subroutine does is quite pretty simple. So you remember, like when you see a list of items in a room, it says like IC and then item 1, item 2, item 3, etc. And then if you pick up the item and then try to see is item still kind of there or not, then you'll see like, okay, no more items. So you just pick the file, there is no more file. You've picked the rope, there is no more rope. You've picked up the cage, there is no more cage. There is nothing literally, okay? And the reason why the objects are disappearing from the certain location on the map is because this delete object routine is kind of triggers, and it just deletes this it deletes the object from the certain location in the map on the map. But the problem is that if you're familiar with the memory layout of the KIM-1, and actually not only the KIM-1, this is specific to whatever 6502 processor based machines. The memory page 1 within the address range from 0100 to 01FF, that's the stack page, and potentially the entire 256 bytes, right, might be used by the stack data. But because of the minimalist RAM of the KIM-1 itself, it only takes, well, in theory, it should only take up to 8 bytes of the stack. So starting from 01FF and growing downwards, no longer than 01F8. Okay, and the very last byte 16 returned from subroutine is located at 01F7. So I was consulting from Bob Leedom and the author of this game, and he said that he has extensively tested the game just to make 100% sure that the stack data would never ever overwrite this delete object subroutine. But the problem is, I don't know why exactly that is happening. Well, probably because of a not 100% accurate emulation, but for some reason it happens that in my case the stack data was overriding the bytes up to around 01F2. So all of these bytes were overwritten by either something that has been pushed onto the stack, or by the memory addresses that were put on the stack when you're calling a function. So whatever they are. And this has resulted in the fact that it's actually when the program counter got here and tried to execute what it shouldn't be ever executing, and most likely in most cases there wasn't even the legal opcode, it was just crashing, and that's kind of pretty much all about it. So what I did eventually in order to solve this, first I was thinking that maybe there is something wrong with the emulator. And I've noticed that when I was, again, a few words about how to upload the program to the KIM's memory. So originally it was intended to be done with the serial communication from the terminal, for instance, and using the paper tape. Another alternative was to use the cassette tape. Well, for this emulator, I didn't have neither of those. And the way I did this, I just made a loop that was directly writing to the emulator RAM, writing the data to the emulator RAM from the assembled data goes strictly into the emulator RAM. And for some reason, when I was doing that, it did result in some strange things happening on the stack. And then I made another little fix to the emulator, which hopefully kind of like makes it a little bit better. So after loading the program, assuming that it's not really intended to be done on like this on the KIM-1, it's not assumed to be done like that. So that's a bit of a hack already. So what I did after, so I was resetting the CPU, and hence the stack was settling down again like where it should be, and actually initially was using only the 4 bytes, which is the case, which should be like when you're not doing anything, it just takes the 4 bytes to print the screen continuously. And I was happy with that, and I was thinking like maybe that's enough to maybe that would be enough to make it work. But unfortunately, when I just run the program and when I see the first message like you're at stream, and then stop the program and go into this address of somewhere at 01EC, then it's just program bytes, and then bam, and we have the stack data. And the stack data overwrites this routine. So to be honest, I had no idea why is this happening. And even when I asked my friend Dominic Benbaka to run this on Corsham KIM, which is a modern KIM clone, it happened that if I just find this somewhere, yeah, here it is. So have a look at what happens. Before running, let's say we upload the KIM Venture to the Corsham KIM. So before running to the address, before running the game, we're going to the address 01EC. Okay, and here is the hex dump. So you see, like, this is the original. So if you just compare this data, you see like this bytes are going here. So we get the original delete object, which is exactly what it should be. However, if you then run the KIM Venture on the Corsham clone, even though for some mind-blowing reason for me, it's absolutely mind-blowing, it still works on Corsham KIM. I don't know how this is possible. But if you have a look at this hex dump, you'll notice that actually at the address 01F7, there is no longer return here. So here should be 600s, which is return, and here F7, it's already has been overwritten. Even it's overwritten. So it's overwritten up until here somewhere. So you see, like, the delete object routine is getting overwritten even on the KIM-1 clone, which is considered to be like 100% so KIM software compatible. And it does work on Corsham KIM, which is absolutely out of this world. So I don't understand how on earth is that possible. But anyway, so maybe, and again, and when I run this in my emulator, a similar thing is happening. Maybe it just overwrites with a slightly different addresses, because even though we have the same ROMs, I'm not sure why exactly, but sometimes ROMs are working slightly a little bit different. Maybe because the lack of timers in my emulation, maybe due to some sort of a different reason, another reason. But anyway, these addresses where the delete object is located are getting overwritten, and that makes the program crash every time. So now the hack. So what did I do eventually? So in this main part, I probably won't find this at the moment, or I will try actually. So there should be 20 stands for jump to subroutine, and the address in little endian order is 0004. Yeah, here are they. So these are the two the two subroutine calls in order to call the delete object within the entire game. So this is the main game code. And here, before mine changes, here were like called not to 0400, but to the address of 01EC instead, where originally delete object is located. But I've changed those, and at the address 0400, this line in particular, I've just put the bytes from this routine, and like so. I took these bytes, grabbed them, and placed them right over in here. And this byte starts at the address 0400. And now, if we just, sorry. So this should be 200004. So and now we're calling. So we've changed the address of the subroutine to call. So now it just calls. Right over in here, and then once return is reached, it just drops back, and then it resumes the execution of the rest of the program. So this is cheating, I know, but I don't know. I think this is better to have a working game with this sort of a hack instead of having a non-working game at all. And the problem is that in this case we do exceed the original KIM-1's memory. So I need to extend the memory. Yeah, you know, like when you're dealing with a real computer, extending the memory, you need to go to the store or order on the internet and then plug the memory in, and there might be some issues. But if you're writing an emulator, the matter of extending the memory is just a matter of making the variable. So I had 1K here, and now I set this to 1700 hexadecimal. So yeah, now I have more memory. Yeah, I actually need to change this sort of thing here as well. So now, yeah, now we have keying with lots of memory, which might not be really historically accurate, but again, like if you want to limit yourself with 1K like I do, you just can use the addresses from 0000 to 03FF, and that would be the 1K of memory for you to use, like as if this was an original KIM. So that's pretty much all I wanted to say today, guys. So yeah, this is a very nice present for me. So this nice little working emulator. So yeah, all the links would have been in the description below the video. So thanks for watching. Until the next time, and take care.